Good afternoon, class.
Good afternoon, Mrs. Bowie.
You can sit down. All right, to start off with today's lesson, we'll have to complete the exercise we did not complete in the previous lesson by looking at questions 12, 13, 14, and 15. So those students responsible, you have to come and do the questions on the board. I think number 12 is bond relay. Come. Chalk there if you want to use the chalk. Can you please pass the mic? Where's the mic? Pass the mic.
The question states that the diagonals of a quadrilateral XYZW intersect at O. Given that OX equal OZ, OX equals OW and OY equal OZ, prove that XY is equal to ZW. Okay, to prove that XY is equal to ZW, I use the rectangle. And we know that both lengths of the rectangle are equal and the opposite sides are parallel. And to prove that YZ is parallel to XW, it's this one. So we have to prove that the diagonals inside are equal. And the diagonals of a rectangle are they are divided into two triangles which are congruent, which means that their hypotenuse will be equal. So because their hypotenuse is equal, and when we divide it, all the sides of the hypotenuse divided will also be equal.
Okay, did you agree? Okay, first of all, you are actually told that it's a quadrilateral, which means it's generally a four-sided figure. All right, you are also given the information that he's correctly got on the board that OX is equal to OW and OZ is equal to OY. Okay, if these two are equal, and these two are equal, he correctly said that means that then that the diagonals are equal. Because if this is the same as this and this is the same as this, then the two diagonals are exactly the same. Then it says prove that XY, which is this, is equal to ZW. Okay, using the angles as well. These two angles are vertically opposite angles. And they are equal. These two are also vertically opposite angles and they are equal. So if that happens, you've got side angle side. That, you know, the test for congruent triangles, you get side angle side. It has to be the angle that is included between the sides. This one too, side angle side. This side is the same as this one is the same as that one, which means triangles WZO and XYO are exactly the same. If they're exactly the same, then you can say that XY is equal to ZW. Okay, I hope you're not just listening and taking note, because when you do an assignment on geometry, I will give you a lot of proving to do. And you'll have to write down the proofs. Okay, you then have to prove that YZ is parallel to XW. Okay, where YZ is parallel to XW. Because the diagonals are equal, okay, because the diagonals are equal, like he explained, the diagonals are equal only in a rectangle and a square. And we all know that in a rectangle and in a square, the opposite sides are parallel. When that happens, that means the two opposite sides will be parallel. So YZ is parallel to XW. Agree? Okay, number 13, Velma. If you want, you can write out your answer too, if you want. Fifteen and 14 now. Let's see. Who's doing 15? You are 15. Boromir is doing 14. Okay.
Question reads, ABCD is a parallelogram. Parallel lines BE and DF meet the diagonal AC at E and F respectively. Prove that AE prove that let's take this angle for X. That angle will be alternate to this angle here. That's also X. So both these angles here will be equal. And because on a straight line, the angles on a straight line all add up to 180 degrees. So 180 minus the outer angle X here will give us this angle here, which is Y. The angle here will also be equal to the angle here. So both these angles are equal and the outer angles are also equal. Okay, this angle up here will be equal to the angle down here because they are alternate to each other. Also, these two angles in this triangle are equal to the two angles in this triangle, which means that the angle here will be also same as the angle here. So we can see from here that all the angles in both these triangles are the same. The test for congruency states that if the angles in two triangles are the same, their lengths will also be the same, which means that the line AF will be equal to the line EC, and BC will be equal to the line AD, and DF will be equal to the line EB, which means that all their lengths are equal and the angles too are the same. So if the line AF is equal to the line EC, then we can now prove that AE is also equal to the line FC. It's just the same as if I close this part of the triangle, we are left with AE, which is just the same as if I close this part. Then the lengths are also the same. B states prove that BEDF is a parallelogram. We can prove that BE and DF are parallelogram because from here we know that the opposite lengths are equal. So that proves that it is a parallelogram.
Okay. I think one important thing that she forgot that's in the information is that these two lines are parallel, because you are told that BE is parallel to DF. And if that's the case, then if they are already equal, then this BE, DF, if these two lines are parallel and equal, then it proves that these two lines will also be parallel, because these angles will also be the same. Okay? Next one, question 14. Velma, you did very well. Boromir.
Question 14 reads, shown below is a parallelogram ABCD. Find A, the size of the angle marked X. Okay, to find the angle marked X,
Mr. Pointer.
we have two given angles already, 96 and 42. Therefore, just add them both and subtract that from 180, you get angle X, which is 42. B, the size of angle marked Y. Okay, Y is, we know that angles opposite each other are equal. Therefore, angle Y is equal to angle X. So angle X is 42 degrees, so Y is 42 degrees. C, the size of angle AC.
ACD is already there. It's okay, just give it.
AC.
Okay. Give ACB.
The size of angle ACB. Okay. We know that this is a parallelogram, therefore this line is parallel to that one, meaning that angle CAD is alternate to angle ACB, meaning they are equal. So angle ACB is equal to 96 degrees. And D, what type of triangle is ACD? It's an isosceles triangle because both angles are equal and when you have two angles equal, that means that it is an isosceles triangle. Thing.
Yeah. Okay, well done. Note C is angle ACB. ACB is 96 degrees. Okay, it's an isosceles triangle, like he said. This is 42 and this is 42, which means this length must be equal to this length. Right, the last question. Megan.
I'm going to find the the length of AO and BO and the outer length of AB. Okay, the diagonals of the rhombus, they cut each other, so 24 divided by 2 will give us the length of AO, which is 12, and 10 divided by 2 will give us 5, which is the length of BO. So since the diagonals of rhombus bisect each other at right 90 degrees, we use Pythagoras' theorem to find AB. So 12 squared plus 5 squared gives us 169, which equals to 13 centimeters.
Thank you. 169 is not equal to 13. The square root of 169 is equal to 13. So AB is 13 centimeters. Is there anyone who wants me to explain a question on the exercise? No? You're all experts now. I'll give you some more questions later on, because we have to go on and look at polygons. Okay, on the screen you can actually see 4 polygons. There's 1, 2, 3, and 4. So by me saying that and you seeing those polygons, what is the definition of a polygon? What is a polygon? Anyone? What is a polygon? I want a volunteer, please. Danielle.
Shapes with more than 4 sides.
Shapes with more than 4 sides, you mean to tell me that quadrilateral is not a polygon? Because a quadrilateral has 4 sides. George, what do you think? What is a polygon?
A polygon is any plane figure bounded only by straight lines.
Okay, a polygon is a plane figure bounded by straight lines. So is a triangle a polygon? Yes, a triangle is a plane figure that is bounded by 3 straight lines. Therefore, it is a polygon. So a polygon is a figure, a plane figure bounded by straight lines. Okay, there are 3 types of polygons. The triangle is a polygon bounded by 3 lines. The quadrilateral is a polygon bounded by 4 straight lines. Okay. There are 3 types of three types of polygons. One is called a convex polygon. Okay, can anyone tell me what a convex polygon is? Siegfried, what is a convex polygon? Pass the mic.
A polygon that has no interior angle greater than 180 degrees.
Okay, a polygon that has
No interior angle greater than 180 degrees.
okay, no interior angle greater than 180 degrees. For instance, this one that I've got on the board, it is a four-sided polygon, but it is a polygon that does not have any angle greater than 180 degrees. All right, second one is called a reentrant polygon. Okay, what is a reentrant polygon? Then,
a polygon which has at least one angle greater than 180 degrees.
okay, a reentrant polygon, like Dan said, is a polygon that has one angle greater than 180 degrees. So if I've got this polygon has 1, 2, 3, 4, 5 sides, and this angle is the angle that is greater than 180 degrees. So a reentrant polygon is a polygon with one, is it one interior angle greater than 180 degrees? At least one interior angle. Or just one angle? Okay. Okay, one angle will be greater than 180 degrees. Okay, the third one is called a regular polygon. That's where a square comes in. So as an equilateral triangle, they are all regular polygons. Kila, what is a regular polygon?
A polygon that is all its sides and angles equal.
Has all its one?
Sides and angles equal.
Okay, has all its sides and angles equal. For instance, a square. All sides and angles are equal, or a right angle triangle is also a regular polygon. All right, the next thing we are going to look at is to find out how we can calculate the sum of the angles in a polygon, in any polygon. Okay, just for interest, what is the polygon with 5 sides called? Rita?
Pentagon.
Pentagon. What about 6 sides? Andrew?
Hexagon.
Hexagon. 7 sides. Vui?
Heptagon.
Heptagon. Taumaku, 8 sides.
Octagon.
What?
Octagon.
Octagon, 9 sides. Kiapin.
Nonagon.
Nonagon. Hekoi, 10 sides.
Decagon.
Decagon. Okay, you can find out what the polygons are when they have 11 sides to 20 sides. That's your homework. Find out the names of the polygons with 11 sides up to 20 sides. Okay, we don't have time for that. Right, what we are going to do now is to find out the sum of the angles in a polygon. And so, for instance, the number of diagonals the polygon has, or any polygon will have, and how to find that out, and also the size of one interior angle of a polygon. I usually don't follow the formula that's given in the textbook. If you have this textbook, you can follow it if you want to, but I have a different way of doing that. Okay, I start off with, first of all, the name of the polygon or the number of sides it has. Sorry, not the number of sides it has, the name. And then this one will be the number of sides. This will be the number of Can you see this? Oh? Okay, number of diagonals. Sorry, my lines are not straight. Number of triangles. I probably should put this before this, but it should work out. And then this one is going to be the sum of the interior. Can I just write INT to mean interior? Angles, I'm going to just write this. So sum of the interior angles, and then this one will be one interior angle. Okay, first starting off with and we use the regular polygons. You cannot use a polygon that's irregular, which is a polygon that has all its sides and angles different. It has to be a regular one. So the first one that we look at is an equilateral triangle. Equilateral triangle. Okay, number of sides is 3. Okay, and an equilateral triangle has 60 degrees each angle. The number of triangles is 1. The sum of the interior angles is 180 degrees. One interior angle is 60. Okay, this is an equilateral triangle. Now we go to a quadrilateral, but then we specifically look at a square. I'm going to just have to draw, so I don't have enough space. So I do have enough space. A square has 4 sides. How many diagonals? 1. You're supposed to draw the diagonal only from one vertex to the other. So there's only 1. How many triangles? 2. 2 triangles. The sum of the interior angles is 360. One interior angle is 90 degrees. Now we go to a pentagon. It has to be a regular one, not like the one I've got, which means all the sides are equal, and all the angles are also equal. A pentagon has 5 sides. The number of diagonals, you have to draw that from one vertex only. So 1, okay, from the same point, 2. Okay, so there are 2 diagonals. I want you to look at the numbers that I've got on the board and see if you can work out what the pattern is. All right, there's 2 diagonals. How many triangles? 3. The sum of the interior angles is going to be 540. One interior angle is going to be 100 and, I don't know if it's 108. Is it 108? Okay, I'm going to stop. You probably know what the pattern is already. Okay, usually in a polygon, okay, now we are going to find maybe some small formulas to find the number of sides and the number of diagonals and so on. Now we are talking about any polygon. It doesn't matter the number of sides. So the number of sides of a polygon is always denoted with the letter n. So this polygon has n sides. How do we find out the number of diagonals it has? Anyone? Put your hand up. How do you go from the number of sides to the number of diagonals? Come on, you can see it there. The answer is on the board. Yes, Kiapin. Have a guess. How do you go from 3 to 0, 4 to 1, 5 to 2?
N minus 3.
N minus 3. Very good. You subtract 3. So if I told you how many diagonals does a polygon with 20 sides have, you just take 20 and take away 3 from it, then you will get 17 diagonals. It must be drawn from the same point, the same vertex. Okay, now, number of triangles. Quick. How do you get to the number of sides? From the number of sides to the number of triangles. Chutaili, can you see a pattern? Give her the mic.
N minus 2.
N minus 2, well done. 3 take away 2 is 1, 4 take away 2 is 2, 5 take away 2 is 3. Okay, now we go to the sum of the interior angles. How do we get the sum of the interior angles of any polygon, knowing that that polygon has n sides? Kyle. Give Kyle the mic.
Multiply by 180 degrees.
Multiply what by 180 degrees?
N minus 2.
N minus 2. Very good. The number of triangles, if you multiply by 180, one triangle in a triangle, you get 180 degrees. Multiply 180 by 2, I get 360 degrees. And this is the number of triangles. So very simply, 180 multiplied by n minus 2. Okay, now, we want the size of one interior angle. Come on, anyone? Livingston. Quick.
Divide by n.
Divide what by n?
N minus 2.
Okay, 180 times n minus 2 divided by n. So n is the number of sides. So 540 divided by 5 gives 108 degrees. 360 divided by 4 gives 90 degrees. Note, this is only for regular polygons. It doesn't work for polygons which have different size angles and different sides. Okay, it works for this. Now, one thing I have to tell you before you go for your next lesson is this. Any polygon usually has an exterior angle and an interior angle. I'll just explain briefly. If a triangle has 3 interior angles, it also has 3 exterior angles. Okay, there's 1, 2, and there should be another one here. There's an interior angle plus an outside one, interior and outside, interior and outside. So there's 1 exterior angle, 3 exterior angles, and angle will also, polygon will also have 3 interior angles. And you will note from this diagram that 1 interior angle plus 1 exterior angle is always equal to 180 degrees. The sum, the sum of an exterior angle, the sum of the exterior angles will always be 360 degrees. Like if you add, the sum of the exterior angles will always be, did I say 360? I hope I'm correct. Am I correct? Okay, the sum of the exterior angles, I try to remember this. I didn't have a look at it again before teaching. I'm just trying to depend on my memory here. Okay, the sum of all exterior angles, it doesn't matter what number of sides it has. It will always be 360 degrees. Which means if you wanted to find the size of one exterior angle, you just divide 360 by the number of sides it has, and it will give you one exterior angle. Okay, but interior angles is different. They have different sums. Exterior angles always 360 degrees. I hope you can remember that because you have a homework to do. It's exercise 35.2 in this textbook, and it has 12 questions. Okay, you have 12 questions to do for homework. All the good students, the keyword to the pilot teacher is Polygons 2. Okay, stand up. Good afternoon, class. Thank you.